Let's warm up with an example showing a situation in which we might make use of the fundamental counting principle. So suppose we're at a restaurant and there's a breakfast special. We get scrambled eggs, a choice of one of three types of protein, and then a choice of two types of toast. So what we want to know is how many different order options will we have? And this is really what these questions are about. How many different outcomes are there? And so we want to kind of visualize our decision-making process as we order breakfast. So we're going to draw a blank space for every stage of breakfast here. And I'll label those, showing that the first stage is the eggs, and then the protein, and then the toast. And of course we might get all of this at the same time on our plate, but as we're making our decision, these are the three stages. Now, in the situation of the eggs, or the decision of the eggs, we don't really have any options. We are offered the scrambled eggs. And we're going to assume for this example that we're not choosing scrambled eggs or none. We're just getting the scrambled eggs. Now, when it comes to the protein, we have three choices. We have the bacon, the sausage, or the ham. This is all listed on the sign at this restaurant, of course, where they clearly communicate what you can choose between. And then we can choose for our toast to either get the wheat or the rye. So we have two choices of toast. Now, what do we do with these three numbers? Well, when we are counting the number of decisions in a situation where we have decision 1 and decision 2 and decision 3, for example, here we have eggs and protein and toast, then we multiply the options together. We'll learn later that in situations where we connect them with the word or, we'll be adding. So if I was having eggs or I was having bacon, sausage, or ham, then I'd be adding those options up because I'm not getting both of them at the same time. But when I'm getting both at the same time, it's a multiplication. So here we have eggs and protein and toast. We're multiplying the 1 and the 3 and the 2 together, giving us 6 order options. Now you might note that if I didn't put the 1 there for the eggs, it wouldn't really change anything. So I like to put every decision with its own space, even when it's a 1. And later this will really help us visualize some situations. So it's a good habit, but it is equivalent if we were to leave it out in this case. Let's say now that the restaurant informs us we can also choose between coffee and juice for a beverage. How many order outcomes are there now? Well, we still have the eggs, protein, and toast, but we've added another decision. The decision we've added is the beverage, and that beverage has two options. So again, whether we write the eggs with the 1 or not, we had the 3 times 2 from the toast and the protein, and now we also have the beverage. So this increases the number of different breakfast outcomes we could have to 12. Finally, what if the restaurant updated itself, its menu, and offered a plant-based option, a tofu patty? Now we have to think for a second, is the tofu patty going with the eggs or is the tofu patty going with the bacon, sausage, and ham? Oh, it says it's plant-based protein and later says how many complete order options are there, including a beverage, with 4 choices of protein. So it's made it pretty clear that the tofu patty is an alternative to the bacon, sausage, or ham, not to the scrambled eggs. So that's not going to change the number of decisions we have. We still have the protein and the toast, and we'll keep the beverage. But what it does is it changes the options for protein from being a 3 to being a 4. And so 4 times 2 times 2, we now have 16 different order options. This kind of process of listing the different decisions and the number of options for each decision is a representation of the fundamental counting principle, which we're going to use in many of the examples to follow.